Let's take a look at systems of linear inequalities. So the only difference between graphing a regular linear inequality and graphing a system of linear inequalities is that now we have two linear inequalities on the same graph. So we did this one in class. I started this one in another video, but we'll get back to it. So I took my two colors and I shaded over my inequalities just to make sure I knew which was which and I could keep them straight the entire time. So I did this one blue and this one pink. I solved this one for y. So I took x minus 2y is less than 4, subtracted x on both sides. So now I had negative 2y is less than negative x plus 4. Then to isolate y, I had to divide by negative 2 on both sides. We have an inequality. When we're dividing by a negative for an inequality, the inequality symbol flips. So now we are left with y is greater than 1/2 x minus 2. I graphed that. Y is greater than 1/2 x minus 2, and it was greater than not equal to, so I used a dashed line. Then I also graphed the blue equation with a solid line. Y is greater than or equal to negative x minus 2. Then I did my test points for each. So at first I just had the dashed pink line and the solid blue line. So I did my test points. Above the line I chose 0, 0. So I plugged my x and y into the inequality. 0, that's my y value of 0, is greater than or equal to negative 0 minus 2. 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to negative 2. That is true. I chose a point below my line. I chose negative 2, negative 2. I plugged them in for x and y. What's important is this is my y greater than or equal to. The inequality gives us a negative x. So even though my x is negative, or especially because my x is negative of whatever my x value is. So this isn't just one negative sign. It's the negative of negative 2. That becomes negative 2 is greater than or equal to 2 minus 2. Negative 2 is greater than or equal to 0, which is false. So I shaded in the region that contains 0, 0, which is above my line. I shaded in, if we're just looking at the blue, I shaded in all above the blue line. Then I did my test points for the other inequality. I chose 0, 0 again. 0, 0 is an easy one to work with because then you end up with 0 somehow and usually, or 0 somewhere when you're multiplying, and it's easier numbers to work with. So x minus 2 times 0, 0 minus 0 equals, not equals, is less than 4. 0 less than 4 is true. And I chose a point below the line. So this is also to express and explain exactly what's happening. So when my x and y values are not the same, this is what it would look like. My x value is 3 minus 2 times my y value of negative 2 is less than 4. So I'm not just putting the same number because my other test points were 0, 0 or negative 2, negative 2. It looked like I was just using the same number in both variables. Yes, but not just because. It's because that was the actual point, those coordinates that I picked. So now I have 3 minus negative 4, 3 plus 4 is less than 4, 7 is less than 4, and that is false. So I then I only look at my pink line. I ignore wherever the blue is shaded. I just shade above the pink line because that's where 0, 0 is. So I shade this whole section. So don't get tricked that, oh, only the blue is shaded here. No, this is still part of this linear inequality. So I shaded here. This section that's shaded, that's kind of purpley now because the pink and the blue mixed, that whole section contains solutions for this system of linear inequalities. So let's take a look at these questions. Is the origin a solution to the system in exercise 5? The origin is point 0, 0. Is the origin in the overlapping shaded sections? Yes, so it is a solution to the system. Is 4, 0 a solution to the system in exercise 5? Let's look. 4, 0. This is a special one because yes, it's in the blue section and it is on the pink line, but since the pink line is dashed, it is not going to be a solution if it's on this line because the line is dashed. So it is not a solution to the system. Then we looked at a couple of other points. Is 3, 1, or sorry, negative 3, 1. Let's zoom out a little bit. So we have both things. Is negative 3, 1 a solution to this system? Negative 3, 1. Now this is on the solid blue line. The solid line for greater than or equal to, this will be a solution. So if it's on the solid blue line, it is a solution. Just like when we did graphing regular inequalities and the dot, the filled in circle, the closed circle was part of the solution, but the open circle was not. The closed line is part of the solution and the open line is not. So negative 3, 1 is a solution. Then we took a look at negative 4, negative 3 down here. That is a solution of the pink equation inequality, but not the blue, so it's not a solution to the system. And 4, negative 3 is a solution to the blue inequality, but not the pink, so it's not a solution for the system. So now let's get back to Zoom 1. And let's take a look at this one. So number 6, I started doing this and then decided I needed to go over number 5 for the flipping inequality symbol. So I started solving this for y. I shaded this inequality red. I wanted to switch up the colors. Started solving this for y. X plus y is less than 3. Subtract x on both sides. Y is less than negative x plus 3. So let's graph that. I notice it's a, this will get a dashed line. It's just less than, not less than or equal to, so it'll get a dashed line. Just like this would get an open circle, it gets an open line or a dashed line. So I find plus 3, and my slope is negative 1. So I go down 1, right 1 for the whole way, and then up 1, left 1 there. I take my ruler and I make this a dashed line. All the way to the end, and I draw my arrows. Let's stick to the graphing, so we're on this side of the page first. Then I can graph, actually, no, let's do one inequality at a time. Last time we did both lines at the same time. Let's just do one inequality at a time. So now let's take the original. X plus y is less than 3. So for number 6, x plus y is less than 3. Let's pick a point above my line. Oops. Above the line, what's this? This is 3, 3. Let's do a different one just so we get the practice of having the x and y being different. Let's do 3, 4 as our test point. Our test point is 3, 4. So we have x, so 3, plus our y, 4 is less than 3, 7 is less than 3. That is false. I have the ring directly in line with the pencil, which didn't happen when the pencils were too short. So that's false. So let's pick a point below our line. We have, let's pick 1, -1 is below our line. So x is 1 plus our y of -1 is less than 3. 0 is less than 3. That's true. So I know my hand was in the way the whole time, so I'll give you a minute to look at it. So now I'm going to shade in the region that contains the point 1, -1. So that's this whole thing here. That's the bottom of the line. It doesn't have to be perfect, but it should be shaded to the end of the page or the end of the graph. And it should be shaded right up to the line so that we know all of it's included. But if it's a little patchy, that's okay. So now let's look at our next inequality. Y is greater than or equal to 3x minus 2. Y is greater than or equal to 3x minus 2. I think it's easier to see on the page with the flash, with the ring light, rather than just looking at the ring light on the page. So you guys have better luck seeing it than I do. So let's pick a point above the line. See, when the pencil is short enough, it's not hitting into the ring light. Oh, let's graph it first, so that we have our -2 down here, and we have our slope of 3x. So that means up 3, right 1, up 3, right 1, down 3, left 1. And that is less than or equal to. So we're going to take our ruler and draw a solid line on this. With my arrows, solid line. So above the line, I'll consider this above the line. We can even call it side A, side B if we want to, but for now, let's do above the line. Let's do -1, +1. -1, 1. So now I plug in 1 is my y, is greater than or equal to 3 times my x, -1 minus 2. 1 is greater than or equal to -3 minus 2. 1 is greater than or equal to -3 plus a -2. So 1 is greater than or equal to -5. This is true. Oops, I totally left the bottom out of the page, out of the screen. This is true. So what I did, plugged in the -1. 1 is greater than or equal to -3 minus 2. 1 is greater than or equal to -3 plus a -2. 1 is greater than or equal to -5 is true. And yes, I could have just gone from here to here, but I wanted to double check and be safe. So let's look at a point below our line. Let's do 3, -2. You can still use 0, 0 if you want to. I'm just making sure that we understand which is which, the x and the y. 3, -2 was my point. So now I have -2 is greater than or equal to 3 times 3, that's my x value, minus 2, -2 greater than or equal to 9 minus 2. It's so hard when you can see through the page. -2 is greater than or equal to 7, which is false. So we are going to shade the region that contains the point -1, 1. So -1, 1 is here. So I'm only looking at my yellow line. I actually like covering it. I covered it with my hand before, but I can't now with the angle. So I'm just gonna cover this section with my ruler. I'm not using it as a guide, I'm just using it as a cover. So I'm going to shade this whole region. And it will happen that there will be a section that only contains one color rather than both colors. So now that I got that started, I'm just going to color this side. This is why I colored light with the orange. Now I'm coloring dark. I spoiled what I was going to say. I colored light with the red and coloring dark with the orange. Just, oh my goodness. Colored light first, dark this time to make orange. Light with the red, dark with the yellow, because yellow is a lighter color. So I wanted to make sure it would actually show and come through. So now this orangey section is the area of the graph that contains solutions to this system. I didn't shade this in. So now let's take a look at these questions. Is 1, 0 a solution to the system in exercise 6? Is 1, 0. So let's see. 1, 0. Is this a solution? Well, I see that it's on my yellow line. It's in my red section and on my yellow line, so yes. Is negative 1, 0, negative 1, 0 a solution to the system? It's in the overlapping shaded section, so yes. Okay. Let's think about some other points for number 6. Let's think about, what about this point? Is 0, what did I say? 3, a point, a solution. It's in the yellow section and it's on the red line, but since it's on a dashed line, it is not a solution. Hold on, I'm checking my work. I don't know why I was hesitant on this. 1, 0, hold on. Okay, so I looked again. I had to look at the answer key. So this is actually no, and here's why. It's because my yellow line is too thick. So here, let me redraw this with a pencil. If this is my point here, it's not that my line was too thick. It's that I think with the ruler, I don't think I placed it correctly. So let me do this with a sharper pencil and a ruler in the correct spot. I knew something was saying, check the answer key, just to be safe. So this is my yellow line now that I have in pencil. And now we can look, and 1, 0. Is 1, 0? That is not a solution. It's not actually on the yellow line. When I look at the pencil line, it's not there. So you do have to be careful with the thickness of the pencil as well. So I should have just written no down here. So this is not a solution, no. Let's go back and let's look at another point. Let's look at, what about 1, 4? 1, 4. It's a solution, 1, 4, to the second one, the yellow one. It's in the yellow section, but it's not in the red section at all. So it's not a solution. We can look at, what about 2, negative 2? As we just saw, that is in the red section, but not the yellow, so that's not a solution. I don't know why I keep writing not instead of no. But if we wanted to look at 0, negative 2, that is a solution. 0, negative 2, yes, because 0, negative 2 is on the solid line, the solid yellow line. And any points in here are also solutions. Okay, let's take a look at this other worksheet. So, I should have paused it. I did not. Too bad. We're okay. So, let's use the yellow first this time. And this one, they are in slope-intercept form, so I don't even need to worry about solving for y. Because they already are. So y is less than or equal to negative x minus 2. So negative 2, wasn't that the equation on the other one? I don't know. Negative 2, I plot, let me sharpen this. Movie magic, it's sharp now. Negative x, we go down 1, right 1. The whole graph. Up 1, left 1. Okay. So it's a solid line. Oh my goodness, it's less than or equal to, so it's a solid line. Well, I hope that part's shaded. It probably won't be. So I'm erasing this. You have to be careful. Here's proof that I am just human, but we're going to ignore this little mistake here. That's okay. We get the idea. And let's do test points. I'm going to get another piece of paper because there's not enough space here. So let's look. We have y is less than or equal to negative x minus 2. So now this is good. We can see the graph and the work at the same time. So above the line, let's go back to our origin of 0, 0. 0 is less than or equal to negative x, which is 0, minus 2. 0 is less than or equal to 0 minus 2 is negative 2. That is false. And let's look at a point below the line. Let's choose negative 2, negative 2. So we have negative 2 is less than or equal to negative of negative 2 minus 2. Negative 2 is less than or equal to 2 minus 2. Negative 2 is less than or equal to 0. That is true. So I am going to shade this section. I actually like to turn my paper to shade. I like shading horizontally. So, yeah. I cannot color and think at the same time and speak, but that's okay. Ooh, punching my equipment. Okay, so I did that one. Now let's look at the other inequality. Y is greater than or equal to negative 5x plus 2. Oh, you couldn't see it. You could if you had your worksheet out. So plus 2, negative 5x. 1, 2, 3, 4, 5. Right. 1, 2. I can't do anymore. We go 1, 2, 3. I can't graph anymore. So I'm just going to connect these 2 points. And it was less than or equal to or greater than or equal to, so I'm going to use a solid line. I know, I just made that line way too thick again, but as long as we understand what we're doing, it's okay. We'll have sharper pencils for the test. Let's shade this so that we know that it's that. And let's do some test points. Nope, we're not doing it on the back, we're doing it over here. So, I'm folding this. So we have y is greater than or equal to negative 5x plus 2. So, let's call it left and right. As long as it can either be left and right or above and below, as long as it's one on one side, one on the other. I'm calling it left and right just because this is such a steep slope that it's easier to visualize left and right than above and below. So on the left of it, let's do negative 1, 1. So 1 is greater than or equal to negative 5 times negative 1 plus 2. 1 is greater than or equal to 5 plus 2. 1 is greater than or equal to 7. That's not true, so it's false. Let's pick a point on the right. Let's do 1, 1. Y is greater than or equal to negative 5 times, nope, sorry, this should be a 1 because we're substituting our values in. 1 is greater than or equal to negative 5 times 1 plus 2. 1 is greater than or equal to negative 5 plus 2. 1 is greater than or equal to negative 5 plus 2 is negative 3. Negative 1 is indeed greater than or equal to negative 3, so that's true. So I'm going to shade the part of the graph that contains the point 1, 1. So that's this side. And I'm going to shade here. So it's the same as the individual inequalities, except now you have two on the same graph. And just make sure that you're focusing on this line. So I'm not only going to shade here, the yellow line isn't telling me where to shade for this. Do you see how I stopped at the yellow line? That's what not to do. So we're going to shade all the way to the blue line. This one was not as fun because the section is so small, but clearly I like using colored pencils and I like using colors that will definitely make another color. So I did the pink and blue to make the purple. I did the yellow and red to make orange, and now we have green. So where this green section is where solutions to the inequality lie, where they end up. So if this graph was bigger, we would have a bigger section here. But it's not that big, so we can only see this little amount here. So this section here, this little triangle, contains solutions to the linear inequality.